So, today we're looking at graphing in standard form, specifically graphing quadratics in standard form. Let's first review the quadratic parent function. That quadratic parent function is y is equal to x squared. All right, the most basic quadratic function, everything comes from this quadratic function. Let's review on what exactly is standard form for a polynomial. So the terms of the polynomial are ordered such that they are in alphabetical order, with the highest degree first, and then they progress from highest to lowest degree, with the constant term last. So what does that look like for our quadratic functions? That means we're going to have y is equal to, and then we're going to have some number multiplied by x squared, plus some other number multiplied by just x, plus that constant term. So it's ax squared plus bx plus c is our quadratic polynomial in standard form. Specifically, it is a trinomial, right, because there's three terms. So, all about the quadratics in standard form. With any quadratic function where the a value is positive, all right, so the a value, meaning this value out front, is positive, the vertex is always going to be a minimum. All right, and that's because if the a value is positive, the graph opens up. All right, versus with any quadratic function where the a value is negative, the vertex is always going to be a maximum. And that's because it opens down. Alrighty, so the axis of symmetry is the vertical line, which can be calculated by using this formula. The formula is x is equal to negative b divided by 2a, which both of these come from the equation. Right, we have an a and a b in the equation. The vertex of the quadratic in standard form has the x-coordinate of the axis of symmetry. So literally, that value that you get out from the axis of symmetry is the same x value as the vertex. To find the y-coordinate of the vertex, you plug in the axis of symmetry value for x. All right, so once you plug in the axis of symmetry value for x into the equation, you're going to get out a y value. That y value is the y value of the vertex. The domain of a quadratic function is always all real numbers. We've talked about this. Or you could just use the symbol. All right, so finding important information in standard form, we need to identify the a, b, and c values. Then we need to start by finding the axis of symmetry, find the coordinate pair of the vertex by plugging in the axis of symmetry, and we can also find the y-intercept. So, example number 1 here. Y is equal to x squared minus 4x plus 2. So the first thing on this x squared is just a 1. That would be our a value. The number on x, just with no power, or the power of 1, is the b value, and then the constant term without an x on it is always the c value. So we have 1, negative 4, and positive 2. So we first should find the axis of symmetry. Axis of symmetry is x is equal to negative b divided by 2 times a. And then we plug in our values. So we know that b is negative 4. So we say negative 4 divided by 2 times a is 1, so multiplied by 1. So that becomes negative is positive divided by 2, which tells us that the axis of symmetry is x is equal to 2. To find the coordinates of the vertex, we plug that 2 back into the equation, right? So we go here and here. That's going to give us y is equal to 2 squared minus 4 times 2 plus 2. So that's y is equal to 4 minus 8 plus 2. 4 minus 8 is negative 4 plus 2. Negative 4 plus 2 gives us negative 2. So that's our y value. So the coordinates of the vertex are 2, comma, negative 2. That first 2 coming from the axis of symmetry. Is the vertex a maximum or minimum, right? That's based off the a value. The a value is positive here. So with a positive a value, means the graph opens up. So if it's opening up, then our vertex is a minimum. And then the coordinate of the y-intercept. Y-intercept, always one of the easiest things to find in standard form. It's literally just the c value. Okay? So you can write 0, 2 as the coordinate of the y-intercept. You also know this by, you can say y is equal to, and then you plug 0 in for x. So 0 squared minus 4 times 0 plus 2. That's 0 minus 0 plus 2, which just gives us 2. Right? So y is equal to 2. And that's how you always find the y-intercept for any equation. You just plug 0 in for x. All right? So let's come down here. We already just found all this information that's filled in for us. This is the same equation. We're actually going to graph it now. Okay? So it wants us to find the x-intercepts, the domain, and the range. It also wants us to fill in this table. In the middle section of this table, you should always put the vertex point. So our vertex point is 2, negative 2. From there, you're going to go up 1 from 2, so that would be 3, and you're going to go down 1 from 2, so that would be 1. Those are the next two numbers we want to plug in, which let's plug those in. Let's plug those in the same color. So let's go y is equal to 1 squared minus 4 times 1 plus 2. So that's y is equal to 1 minus 4 plus 2. 1 minus 4 gives us negative 3 plus 2. So y is equal to negative 1. So then we have negative 1 for 1. Let's also try 3 now. So y is equal to 3 squared minus 4 times 3 plus 2. So 3 squared is 9. 4 times 3 is 12 plus 2. So 9 minus 12 is going to give us negative 3. So this is equal to negative 3 plus 2, which again equals negative 1. Which, if you remember back from the other day, should make sense, right? Because it's symmetric. So you go one away in each direction from the vertex, and it should give you the same exact y values. All right? Which means if we go 2 away, so 4 and 0, we should again get the same exact values. Have we plugged in 0 for x anywhere else in this problem? If you look, yes, right? Let's make this work a little bit easier. We've already plugged 0 in for x one time. It gave us the y-intercept, so that's 2. And if you're starting to follow the pattern, because this is 2 away from the vertex, and 4 is 2 away from the vertex, 4 is also going to be 2. If you want to double check by plugging it in, by all means, go ahead and double check. But I promise you, if you move an equal distance away from the vertex, the y value is going to be the same. So let's graph this. We have 2, negative 2 is right here. And then we have 1, negative 1. And then we have 3, negative 1. And then we finish with 0, positive 2. And 4, positive 2. We graph this equation. And look at that, right? Beautiful quadratic. So domain is always the same, all real numbers. Range is easiest to see from here, right? The lowest value that we get is this negative 2 from the vertex. So then we're growing up from there, so it means our y's have to be greater than or equal to negative 2. All right? So that's how we're going to graph in standard form. You have to find all of these things, which I get it. It's a little tough, right? But we're going to get there, okay? In this case, it's asking for x-intercepts, right, in our box here. The x-intercepts aren't very, very nice in this particular equation. Okay, they're going through at not whole numbers right there. So just estimating right now is okay for our x-intercepts here. So this looks like it's about 1/2. This looks like it's 1, 2, 3, 1, 2, 3.5, right? So this would be 3.5 right here. So if we're writing these x-intercepts, we would say it's 1/2 or 0.5, comma 0. The other one we said was 3.5, comma 0. And that's just estimating, right? You would need a, I guess we can check that, right? We can check to see how close that value is. If we plugged in 0.5 and 3.5 into the equation there. All right? But just the estimation for these x-intercepts is okay right now, guys. All right, example number 2 here. So we have negative x squared minus 8x. So this negative x squared, that is going to be what? Negative 1 for an a value, right? So our a value is negative 1. B value, negative 8. And then our c value, there is nothing here, right? The other way to write nothing is just 0 in mathematics, because this is technically plus 0, plus nothing. So that's our c value. All right, so let's find the axis of symmetry. Remember, axis of symmetry comes from this equation. X is equal to negative b over 2 times a. Negative b would be negative 8 over 2 times a, which would be 2 times negative 1. So that's positive 8 over negative 2, which gives us negative 4. So our axis of symmetry is x is equal to negative 4. Then we find the coordinate of the vertex by plugging in negative 4. So y is equal to negative 4 squared minus 8 times negative 4. So that gives us negative multiplied by 16, because negative 4 squared is 16. Negative 8 times negative 4 is positive 32. Positive 32 minus 16 gives us positive 16. So then our coordinate of the vertex is going to be negative 4, comma 16, because that was the y value we got out when we plugged in negative 4. Is this a max or a min? Well, our a value, swap colors here, our a value is negative. So that tells us that it opens down, right? So it opens like this. So then our vertex right here is going to be a maximum. Coordinate of the y-intercept, remember that's the c value. In this case, c value is 0, so we're 0, comma 0 for the coordinate of the y-intercept. Remember, you can also just plug 0 in for x, so y equals negative 0 squared minus 8 times 0 plus 0, so that's 0 minus 0 plus 0, which is 0, right? So we know that we have 0, 0 as a point. We also know the vertex is negative 4, positive 16. So negative 4, positive 16 puts us right here. And as always, in the middle, you put the vertex in our table. So negative 4, positive 16. The rest of these things, x-intercepts, domain, and range, easiest to find with the graph. We always know domain is all real numbers, though, so we can always put that. So, as I said, you want to go up 1 from negative 4 and down 1 from negative 4. So, going up 1 from negative 4 would give us negative 3. Going down 1 from negative 4 would give us negative 5. And then we just need to plug those things in. So, sorry, let's change this color again. Make it pink. And then we'll plug those values in, right? So we're going y is equal to negative 3 squared minus 8 times negative 3. So it's y is equal to negative 9 plus 8 times 3 is 24. Negative 9 plus 24 is going to give us positive 15. So we have 15 for negative 3. And remember, going 1 in the other direction should also give us 15. So negative 5 is going to be positive 15. Negative 3 is going to be positive 15. And then the nice part about this one, guys, is we already know that 0, when we plug in x, gives us 0. So then you can think about, well, how many steps away is negative 4 from 0? That's 4 steps. So then if we went 4 steps in the other direction, which would take us to -8, right? Because you went +4 to get here, so you go -4 to get to -8. And at -8, we're also going to get a 0 out. All right? And that's because, remember, equidistant from the vertex, so 4 away in each direction, is going to yield the same y values. All right? And then you graph this. Check it out. Oop. Should look just like a quadratic. All right? So x-intercepts, we just found them. 0, 0, that first one. And then we also found that -8, 0 is the other x-intercept. And then the range for this one, the highest point is 16, so all of our y's are less than or equal to that because all of our y's are going down. So less than or equal to +16. Okay? And that's how you're going to graph in standard form. As always, if you have questions, message me in Canvas. I hope you guys have a great day.